Good day, I'm James Carlos Salvador and I'm here to share with you my P6 Big-ptask and Mini-ptask. Ever witnessed the breathtaking spectacle of pilot taking control and executing loop-the-loop? Are you wondering how when doing the loop-the-loop, pilots prevent themselves from falling victim to that? The center of gravity force prevented the pilots from falling during that stunt. Because that force was stronger than the gravitational force dragging it down, it kept the pilots from falling. Hello, today let's dive into the fascinating realm of Kepler's 3 law of planetary motion for Mini-ptask number 2. From the elegant dance of celestial bodies to the rules of governing their orbits, we're about to unravel the mysteries that Johannes Kepler uncovered. Join me for a cosmic journey through the laws that govern our planet's movement in the vast expanse of space. Kepler's first law of planetary motion. According to Kepler's first law of planetary motion, the Sun is one of the two focal points and elliptical orbits that the planet make orbiting it, which indicates celestial asymmetry in their cosmic ballet. Kepler's second law of planetary motion. Equal regions are swept out at equal intervals during a planet orbit around the Sun, according to the law of equal region, often known as Kepler's second law. This implies that a planet moves faster when it is near the Sun and slower when it is farther from it. Understanding the mechanics of planetary motion requires an understanding of this law, which has significantly increased our knowledge of celestial physics. This equation, which mostly relies on the conversion of angular momentum, illustrates how a planet's speed varies to maintain equilibrium in its orbit. The third law of planetary motion. Kepler formulated the third law of planetary motion in the early 17th century. It asserts a relationship between a planet orbit period and average distance from the Sun. According to this formula, the cube of planet's semi-major axis is directly proportional to the square of its orbital period. Stated in various ways, it demonstrates the planets with greater distance from the Sun requires more time to complete their orbits because of its greater distance from the Sun than Mercury, which completes its orbits in 88 days. Neptune takes many years to. The third law of planetary motion. Kepler formulated the third law of planetary motion in the early 17th century. It asserts a relationship between a planet orbital period and average distance from the Sun. According to this formula, the cube of a planet's semi-major axis is directly proportional to the square of its orbital period. Stated in the various way, it demonstrates that planets with greater distance from the Sun requires more time to complete their orbits because of its greater distance from the Sun than Mercury, which completes its orbit in 88 days. Neptune takes many years to complete a full rotation. I'm here to talk about how Newton arrived at his law of universal gravitational force for Mini-ptask number 3. It all started when, as he lay beneath the apple tree, the fruit unexpectedly fell to the ground, causing him to consider the theory of universal gravity. According to the law of universal gravitation, every particle of matter in the universe is drawn to every other particle by force that is inversely proportional to the square of the distance between their centers and directly proportional to the product of their masses. The motion of earthly objects and celestial bodies is governed by the fundamental concept. Here is an example to help you understand our logic better. Having recently completed his first physics course, Noah Formulas devised a new business plan based on his teacher's physics for better living theme. Noah learned that objects weigh different amounts at different distance from Earth's center. His plan involves buying gold by the weight at one altitude and then selling it at another altitude at the same price per weight. Should Noah buy at high altitude and sell it at low altitude or vice versa? The answer to that problem is that Noah should purchase gold in high altitude region and sell it in low altitude region. Since the weight of the gold will decrease in high altitude location and increase in low altitude region, resulting in larger profit than usual. Hey there! Ever wondered why roller coaster defy gravity keeping us securely in our seat when twisting upside down? It's all about the fascinating interplay of forces. Join me as we explore the thrilling science behind roller coaster, from the centripetal force to the need for speed that keeps us safe during those exhilarating loops. Buckle up for a journey into the physics of roller coasters. Are you wondering how roller coasters operate and why, when we ride them, we never fall out of the loop? The centripetal force, which is created by a roller coaster speed, is the explanation behind this. It causes us to drag ourselves into our seats so that we won't fall out when the ride turns upside down. We wouldn't tumble out of it because of the force of the and the seatbelt, of course. Are you also curious as to why when a roller coaster flips over, it does not collapse? The speed at which it falls causes it to hold its position and accelerate its roll toward the loop. In summary, a roller coaster needs speed to function properly. Thank you for listening. Goodbye.